Today we are going to do another problem based on the Sophie Germain identity, and this problem is from the 1987 Aime examination. It was the problem number 14, which means it was pretty tough because Aime is the examination that you take in the United States of America to get into the International Maths Olympiad team of America. By the way, this channel has got a new name, the Math Enthusiast, because I realized that we were making more videos on math than on science. So thank you for watching. This is the question from the Aime, and this is this monster right over here divided by this monster right over here. You have to solve for the expression, and the answer will come an integer. Okay, so wish of luck. And trust me, the only thing that we are going to use here is the Sophie Germain identity. So let's recall what Sophie Germain identity says. That says that if we have an expression a to the power 4 plus 4 times b to the power 4, we can evaluate it as a plus b squared plus b squared multiplied by a plus a minus b squared plus b squared. Right. Now we are going to use the same thing for this one. Let me just rub this off. If you have not viewed the video on the Sophie Germain identity yet, I recommend you to watch that first. Link down in the description below. So let's try to write it as something to the power 4 plus 4 times something to the power 4. This is 10 to the power 4 clearly, plus 4 times 81. Is 81 something to the power 4? Yes, it's 3 to the power 4. Which means that we can use the Sophie Germain identity in order to factor this. How can we factor it? The first expression will be factored just like this. The first one, 10 to the power 4 plus 4 times 3 to the power 4. So 10 plus 3 squared by the Sophie Germain identity plus b squared. The b is 3 right over here. In fact, in each of these terms, the b will be 3. Okay. This is 3 squared multiplied by 10 minus 3 squared plus 3 squared multiplied by, we can factor this as in the same way. 22 plus 3, 25 squared plus 3 squared, and the reason we are doing that is because of the Sophie Germain identity. Then this one is going to be 22 minus 3, which is 19 squared plus 3 squared, and this one we can factor it as 34 plus 3, 37 squared plus 3 squared multiplied by 34 minus 3, which is 31 squared plus 3 squared. This one we can again write it as 46 squared. In fact, 46 plus 3 is 49 squared multiplied by, I don't know, okay, 49 squared multiplied 49 squared plus 3 squared into 46 squared plus 3 squared, right? And I forgot to add one more term over here. You know, there's 58 squared as well. Okay, so I apologize for that. That's 58 squared is also there, and 324 is also there, and this one is 52 square, 52 to the power 4 plus 324. Sorry for that mistake, but let's go ahead and do that. 58 plus 3 plus 61 squared plus 3 squared to 58 minus 3, that's 55 squared plus 3 squared. Now we are going to divide this whole thing, and you might be thinking this is even more messy. It has got more terms than that one. Oh, what am I going to do now? But let's look at the denominator as well. This can be factored as 4 plus 3, 7 squared plus 3 squared. 4 minus 3 squared, this 1 squared plus 3 squared. Then this can be factored again as 4, in fact, this can be factored as 16 plus 3 is 19 squared plus 3 squared into 16 minus 3, 13 squared plus 3 squared. This can be factored as 28 plus 3, 31 squared plus 28 plus 3, 31 squared plus 3 squared. 28 minus 3 plus 3 squared. 28 minus 3 squared is 25 squared plus 3 squared multiplied by, we factored this one out, now we are going to factor this one out. 40 plus 3, 43 squared plus 40 plus 3 squared, 43 squared plus 3 squared multiplied by 40, in fact this one is 43, I realize the mistake right now. Okay, 43 squared plus 3 squared, this is 37 squared plus 3 squared, and that one, this term, can be written as 52 plus 3, 55 squared plus 3 squared into 52 minus 3, 49 squared plus 3 squared. That's the way we factor it out using the Sophie Germain identity. Now we are going to do some magic. We're going to cancel things out. This one, just have a look, this one cancels with that. 1 squared plus 3 squared is going to remain like that. 19 squared plus 3 squared, find its match. 13 squared plus 3 squared in the denominator, 13 squared plus 3 squared in the numerator, you're going to cancel them out. 31 squared plus 3 squared in the denominator, 31 squared, okay, here you have got this one. 25 squared plus 3 squared, gone. 43 squared plus 3 squared, and there is another 43 squared plus 3 squared. 37 squared plus 3 squared, that one's right there. 55 squared plus 3 squared, right there. 49 squared plus 3 squared, just like that. What are you left with? In the denominator, we are left with 1 squared plus 3 squared, that's 10. In the numerator, we are left with the only term, this one, 61 squared plus 3 squared. What is 61 squared? Well, 61 squared is 3761. Yes. Plus 9, 3730. We are going to cancel that out, and our answer is 373. Whew, nice. Thank you for watching.